Hello students, let's learn some more sums in exercise 14.3. Question number 5. Name the quadrilaterals which have both line and rotational symmetry of order more than 1. So we have to find a quadrilateral which have line and rotational symmetry of order more than 1. So in question 4 already we have discussed three quadrilaterals: square, rectangle and rhombus. That square has order of rotational symmetry, it is 4. Rectangle order of rotational symmetry is 2, and for rhombus order of rotational symmetry is 2, and these are quadrilateral. Now what is the line of symmetry for square? It is 4. Rectangle it is 2, and rhombus it is 2. So these are the examples of the quadrilateral which have line and rotational symmetry of order more than 1. Square 4, line of symmetry 4, order of rotational symmetry it is 4. Rectangle, line of symmetry 2, order of rotational symmetry it is 2. And rhombus, line of symmetry it is 2, and order of rotational symmetry it is 2. Next question, question number 6. After rotating by 60 degree about a center, a figure looks exactly the same as its original position. At what other angle will this happen for the figure? So it is given that for a certain figure, when we rotate it at an angle of rotation 60 degree, we get exactly same figure which was at the first place, that is original position. So we get rotational symmetry at 60 degree. Now next we have to find other angles. So what are the other angles? That means nothing but when this shape is at 60 degree angle as compared to its original position, then we have to rotate it for another 60 degree angle, that is 60 plus 60, it is 120. So at 120 degree angle from its original position, we get exactly same figure which looks like its original position. Next angle we will get, that is at 120 degree, when we rotate for a 60 degree, that is 120 plus 60, we get 180. So in 180 we get another copy of the figure which exactly looks like its original figure. Next in 180 degree, again 60 degree, that is 180 plus 60, that is 240. And in 240 60, that is 300. And at 300 we add 60, we get 360, that is full rotation. So what is the order of rotation? It is of course 6. 1, 2, 3, 4, 5, 6. The question was we have to find the angles at which angle we get rotational symmetry, that means exact copy as comparing its original position. So angles are, that is 60, then 120, 180, 240, 300 and 360. Last question of this exercise and also of this chapter, question number 7. Can we have a rotational symmetry of order more than 1 whose angle of rotation is number 1 45 degree and number 2 17 degree? So first for 45 degree, we have already learned that angle of rotation is equal to nothing but 360 divided by order of rotational symmetry, and order of rotation is equal to 360 divided by angle of rotation. So here first we will assume that 45 degree is a angle of rotation for some figure. So from this formula we can write 360 divided by angle of rotation, that is 360 divided by 45.
Now if 360 is divisible by 45, that means by dividing 360 to 45, if we get a whole number, then we can say that 45 degree is a angle of rotation for the figure. That means 45 should be a factor of 360. So here we will check 360 divided by 45, and directly 45 adds up, we get 360. So by dividing 360 to 45, we get 8. So here we can write order of is equal to 360 divided by 45, that is equal to 8, and it is a whole number. That means if angle of rotation is 45 degree, then we get order of rotational symmetry for such figure which have angle of rotation 45, we get 8, order of rotational symmetry 8. So yes, our answer is yes, that for 45 degree angle we get a rotational symmetry order more than 1. Next, 17. For that we will check that 360 is divisible by 17. That means 70 is a factor of 360 or not. So 360 divided by 17. 17 twos are 34. 36 minus 34, that is 2. Here 0, it is 20. 17 ones are 17. 20 minus 17, that is 3. So here remainder is 3. That means 17 is not a factor of 360, and therefore we can't get a rotational symmetry of order more than 1 for this certain angle. So answer is no.